So, hello everyone. Today we are going to start a new chapter, which is chapter number 2 from Geography Class 6 NCERT book. And the title of this chapter is Globe, Latitudes and Longitudes. So, I think so, children, whenever you are writing something in a plain sheet of paper, so what does your teacher ask you to do? Your teacher asks you to make margins. Okay, so why do you think your teacher asks you to make a margin then write on a plain sheet of paper? So the answer is very simple, so that you could have or so that or you so that you could have a certain you could say a reference point to start somewhere in the page. If you don't have a margin in the page, it would be very random and you could write anywhere in the page and it would not look proper. So same thing happens with the latitude and longitudes also. So if you want to know where exactly a position is on the earth, we use latitude and longitudes to take it as a reference. Okay, and we take it as a reference, and when we take it as a reference, we would be able to know the position of anything. I mean, in a place. Okay, it could be a place which you want to know in a globe. Okay, so latitude exactly is something, it's actually an imaginary line basically, which is used to determine a position of any place or area in a globe, or you can say in short on earth. Okay, so we would be able to know more about latitudes and longitudes in this chapter as we read line by line in this chapter. Okay, so in the previous chapter they are saying you have read that our planet earth is not a sphere. So obviously, as you know, our earth is not a sphere. It is slightly flattened at the north and south poles and bulge in the middle. So that is the nature of earth's shape. So earth is basically flat on both north and south poles. Okay, and it usually bulges out, means it is kind of more spreading in the middle part of the section of the of itself. Okay, so can you imagine how it works? You may look at a globe carefully in your classroom to get an idea. So that means they are exactly asking you to look into a globe to exactly understand what could be the shape of the earth. Okay, so globe is a true model of the earth. So basically you could say globe, this thing, okay, if you may notice here children, is exactly a globe. Okay, and globe is a true model, means it's not exactly uh, earth, but it could be considered to be such a figure or such a model or structure which resembles earth's structure. Okay, so earth may be of varying size and type. Big ones, which globes may be varying size and type. Big ones, which cannot be carried easily. Small pocket globes and globe-like balloons, which can be inflated and are handy and carried with ease. So globe could be of any structure, size. It could be pocket size, it could be large, it could be balloon like, it could be inflated. So those are the things which is being said about globe. Okay, so it is in variety of structure and kind. Okay, so the globe is not fixed. So globe is basically not fixed structure, it could vary. It can be rotated the same way as a top spin or a potter's wheel is rotated. Okay, so you could as the earth rotates on its axis, even a globe could rotate on its axis the way a top or a potter's wheel basically rotates. Okay, so on the globe, countries, continents and oceans are shown in their correct size. So in on the globe, what you would find is countries, continents and oceans are basically shown. Okay, so it is difficult to describe the location of a point on a sphere like the earth. So it is kind of difficult to exactly know where a position of any place is on the globe. Okay, now the question arises as to how to locate a place on it. So that means obviously if you want to know where is which place on globe or on earth, so what could be a proper way to do so. Okay, so we need certain points of reference and lines to find out the location of those places. So obviously we need some reference, so which I was talking before. So obviously what could be the reference, children? It could be latitude and longitudes. So that is the simple answer for it. Okay, so you will notice that needle is fixed through the globe in a tilted manner, which is called its axis. So obviously we have a supporting structure which is in the center of the globe. Okay, so if you may notice over here on the top over here and on the bottom on this side in the globe, okay, there is a needle like structure which supports the globe. So this structure has a special name which is called axis. Okay, so two points on the globe through which the needle passes are two poles. Obviously that means it resembles the 2 points on the north and on the south of the globe, usually resembles the north pole and south pole of the earth. The globe can be moved around this needle from west to east just as the earth moves. So the way earth moves around the around itself. Okay, so there's an imaginary axis like structures, you could say, or you could, I mean, there would be an imaginary center on the earth which is through which or around which the earth usually rotates. Okay, but remember there is a major difference. So there is basically a major difference between this thing, okay, the axis and the real axis of the earth. Okay, the real earth has no needle, so obviously globe has a needle which helps it helps the globe. Okay, and the needle helps the globe to rotate, but on earth we don't have a exact structure like axis, but still earth rotates on itself in an imaginary line. Okay, so it moves around its axis, which is the imaginary line which I was already talking about this. Another imaginary line running on the globe divides it into two equal parts. Okay, so this is known as equator. So there's another imaginary line which so you might be wondering why we are calling it imaginary, because it is not there on earth, but we are just considering it. Okay, did you understand? So the northern half of the earth is known as the northern hemisphere, and the southern half of earth is obviously known as the southern hemisphere. They are both equal halves, therefore the equator is an imaginary circular line, and it is a very important reference point to locate places on the earth. So that is the reason why, it means, as you know, equator is dividing the earth into two equal parts. So that's why you could say equator is a very important line which divides the earth into two equal parts. Okay, so all parallel circles from the equator up to the poles are parallel of latitudes. That means all the lines which is above or below the equator is usually parallel, they are parallelly rounding the earth. Okay, so and they are called as parallels of latitude because they are parallel to one another. Now you might be wondering what is parallel. So parallel are it's a mathematical term, you could say. Okay, any line which is running along with one another without touching or intersecting, those lines are called as parallels. Okay, so that is the reason why, if you may notice, the two lines of parallel which is above equator, they never intersect at any point on the earth. Okay, so that is why they are parallel. Latitudes are measured in degrees. So obviously latitude would be measured in degrees, so it is also a mathematical term. The equator represents the 0 degree latitude. So usually equator is considered to be 0 degree. That means any line which is above equator, okay, would start its measurement from 0 degree and above, okay, like 0, 1, 2, so okay, and it would go till 90 degree, okay, and it is happening both on northern part and southern part respectively. So any degree measurement or any parallel line which is above equator would have a degree measurement and north as a suffix, okay. So you could say 20 degree north if the line is above equator, and if it is below, then you would say same thing, you would use a degree measurement as well as a suffix south to it, okay. For example, 20 degrees south, 30 degrees south, 90 degrees south, okay. So that is the basic reference, or you could say basic way of naming the latitudes which is above and below the equator. The equator represents the 0 degree latitude, as I've already told you. Since the distance from the equator to either of the pole is 1/4 of the circle around the earth, it will measure 1/4 of the 360 degree, that is 90 degrees. So in here they are saying that as because the distance from the equator to the pole is just 1/4, okay. So that means if you divide, so what they are trying to say is, if you divide earth into 4 different parts, okay, the distance between the equator and the pole is that much. So as because our earth is kind of similar to having a spherical structure, and a full circle, as you already know, always has a measurement of 360 degree, and 1/4 of 360 degree is 90 degree. So that is the reason why the measurement from the equator to the north pole is 90 degree, and same thing happens from equator to south pole is 90 degree again, with suffix north and south respectively. So thus the 90 degree north latitude marks the north pole, and 90 degree south latitude marks the south pole. So as I've already told you, so as all parallels of the equator are called north latitudes, similarly all parallels south of equator are called south latitudes. So obviously all the latitudes which is above the equator would be called as north latitude, and all the parallels which is below the equator is called as south latitudes. The value of each latitude is therefore followed by either the word north or south. So this I have already explained to you. Generally this is indicated by letter N or S. That means if you are supposed to say, then you would say 20 degree north or 20 degree south, but when you will write it, you will say 20 degree N, okay. So you will write 20 degree symbol and N. Same thing you would do if you want to write 20 degree south, 20 degree symbol and S, okay. For example, both Chandrapur in Maharashtra and Belo Horizonte in Brazil are located on parallels of 20 degree latitude, okay. So it means, as you know, Maharashtra and Brazil is 2 different places, but they both lie on 20 degree. So what is the major difference between them? One lies on the north pole and one lies in the south pole. That is the simple difference, okay. But the former is 20 degree north of the equator and the latter is 20 degree south, which means Maharashtra is on 20 degree north and Brazil's Horizonte, okay, there's a place on Horizonte which is 20 degree south, okay. So there is the major difference. We therefore say that Chandrapur is located at 20 degree N, means 20 degree north latitude, and Belo Horizonte is situated at 20 degree south latitude, which is in Brazil, and as you know, Maharashtra is in India. So we see the figure 2.2 that as we move away from equator, the size of the parallel of the latitude decreases. So what is the simple explanation which is being said over there? They're saying that means as you move away from the equator, the size of the parallel of the latitude also decreases. So obviously children, as you know, if you consider a simple spherical structure, so the center part has the longest measurement, and as you go higher and higher on the top, the size decreases. So that is what is the simple explanation. Okay, so important parallels of latitudes. That means now they are discussing some important parallels of latitudes. Beside equator, which is 0 degree, the north pole 90 degree, and south pole 90 degrees south. Okay, there are four important parallels of latitude, so we would be discussing some more facts over here. So as you can see over here in this diagram also children, they have clearly given the example of the important latitudes. Okay, so at 0 degree you will get equator, at 23.5 north you would get Tropic of Cancer, and at 66.5 degree north you would get Arctic Circle, at 23.5 south you would get Tropic of Capricorn, and at 66.5 degree south you would get the Antarctic Circle. So we would be discussing about those lines also in depth. Okay, so Tropic of Cancer, which is 23.5 north in the northern hemisphere, and Tropic of Cancer Capricorn 23.5 south in the southern hemisphere. Arctic Circle at 66.5 north of equator, Antarctic Circle at 66.5 north of the equator. So that is what is being said. Okay, so they are giving us the degree measurement. Okay, so now we would be discussing what are the heat zones of the earth. So heat zones, by the name itself we can understand, they are some places on the earth where the level of sun, okay, is affecting the area or the zone. Okay, and as you know children, the sun, which is the rays of the sun which is falling on the earth, is different because of the angle at which the earth revolves, or you can say rotates. Okay, so rotation as well as revolution of earth around the sun affects the angle at which the rays of the sun falls on it, which basically creates a particular region on the sun, on the earth I mean, which has different levels of heat experienced by it, which causes a certain area. Okay, and those areas on earth is called as heat zones. So we would be discussing more in depth about those zones. Okay, so let us read and try to understand. The midday sun is exactly overhead at least once a year on all latitudes in between the Tropic of Cancer and the Tropic of Capricorn. So that is what is being said. So in here that means they are saying in the midday, that means when the time is around 12 o'clock till 1 o'clock, that is usually a midday period of the sun to fall on the earth. So the time the sun is usually overhead. Okay, so in here they're saying the midday sun is exactly overhead at least once a year on all latitudes in between the Tropic of Cancer and the Tropic of Capricorn. So Tropic of Cancer and Tropic of Capricorn is such an area on the earth which never misses the rays of sun falling on it. Okay, and the areas between them are the areas which always experiences overhead sun throughout the year at least once. Okay, so that is what is being said. This area therefore receives the maximum heat and is called the torrid zone. Means as because this area always receives maximum sunlight from the sun, so that is the reason why it is called torrid zone. So torrid zone is such an area where the maximum heat or light is being experienced from the sun on earth. Okay, so the midday sun never shines overhead on any latitude beyond Tropic of Cancer and Tropic of Capricorn. So those areas which is above Tropic of Cancer and below Tropic of Capricorn is usually not experiencing any sunlight, or you could say, that is a wrong phrase, please excuse me, not any sunlight, minimum, or you can say least amount of sunlight as compared to the areas or region which is in between Tropic of Capricorn and Cancer. So the angle of the sun's rays goes on decreasing towards the pole. So as we move towards the pole, the level of sunlight falling on those areas is less, because the angle is very you could say steep. Okay, and because the angle is very steep, the sunlight or the sun's heat could not reach this region as properly as it does when it is between the Tropic of Cancer and Tropic of Capricorn. Okay, so as such, the areas bounded by the Tropic of Cancer and the Arctic Circle in the northern hemisphere and the Tropic of Capricorn and the Arctic Circle in the southern hemisphere have moderate temperature. So these are therefore called the temperate zones. So temperate zones are usually between the Arctic Circle and the Tropic of Capricorn and the Antarctic Circle, and the Tropic of Capricorn and Antarctic Circle and the Arctic Circle and the Tropic of Cancer. The areas between them is basically called the temperate zone because the sunlight falling on it is minimum, okay, or you could say least. So the areas between the Arctic Circle and the North Pole on the northern hemisphere and the Antarctic Circle and the South Pole in the southern hemisphere are very cold. Obviously the reason is very simple, the sunlight falling on it is minimum. Okay, so it is because where the sun does not rise much above the horizon, therefore its ray are slanting and provide very less heat. Okay, so as because the sun's rays are quite slant on it, okay, on this region basically, so that is the reason why this area is receiving minimum sunlight and this area is very cold, and that is the reason why this zone or this area itself is called as the frigid zone. Okay, so now let us try to understand what are longitudes. Okay, so that means till now, if we recap, latitudes were parallel lines, or you could say horizontal lines, okay, which was running across the earth, okay, and it was becoming shorter and shorter as we move towards the poles. Okay, and one more thing we learned, that based on how the sun falls on the earth, the latitudes help us to categorize the various heat zones. Okay, so there were 3 heat zones: torrid, temperate and frigid. So you could revise one more time by rewinding the video once. Okay, exactly where are those zones, okay, between which 2 latitudes. Okay, so if you know that, most of your knowledge could be inculcated from there. Okay, so let us now try to understand what is longitude. So if you may notice in the diagram over here in figure number 2.5, longitudes are vertical lines which is running all over the earth. Okay, so we could see properly over here. So as you know, as we have already discussed, that a latitude equator used to divide the earth into 2 equal parts, okay, which is northern and southern hemisphere. But what would longitude do is, it would still divide the earth into 2 equal parts, but it would divide the earth into western and eastern hemisphere. Okay, so that is the major difference between a longitude and latitude. Okay, so to fix the position of a place, it is necessary to know something more than the latitude of that place. So obviously we need to have a proper coordinate of any place, so we could not use a single line of reference, so we would use 2 different lines. Okay, so when we use that, it would be better to jot out, okay, the exact position of any place on the earth. So that's why we take a help of longitude. You can see for example that Tonga Island in the Pacific and Mauritius Island in the Indian Ocean are situated on the same latitude. Now, in order to locate them precisely, we must find out how far east or west these places are from a given line of reference running from the north pole to the south pole. So as you know, children, okay, as it is being said over here, that both the two different places, which is Tonga Island and the Mauritius Island, okay, they both are in the same latitude, but we don't know how much far or how precise, what is their precise or what is the exact location of these two places, because if they are in the same latitude, it does not mean basically that they are together, or because if you may know, they are quite far from one another. So what is the way to locate it? So obviously the answer is with the help of longitude. Okay, so now in order to locate them precisely, we must find out how far east or west these places are from a given line of reference running from north pole to the south pole. These lines of reference are called meridians of longitude. So as you know, what are longitude called as? They are called parallels of what are latitude called as? They are called parallels of latitude, but longitude would be not called as parallels, they would be called as meridians of longitudes, and the distance between them are measured in degrees of longitude. So obviously the distance between them obviously is measured in degree of longitudes. Each degree of this is further divided into, just a second, each degrees is further divided into minutes and minutes into seconds. These are semicircles, and the distance between them decreases steadily polewards until it becomes zero at the poles where all the meridians meet. So obviously what happens is the distance between the meridians, or you could say the longitude, is maximum at the center of the earth, but as you go towards the poles, okay, its distance usually decreases. Okay, the distance between the two meridian usually decreases because as you know, when we go towards the north pole, the lines usually shrinks, okay, so that it could reach the poles. Okay, so that is the reason why the distance between the two longitude decreases as they go, or as they extend towards the pole. Okay, so unlike parallels of latitude, all meridians are equal length. So as we know, your latitudes usually decreases its size as we go towards the pole, but meridian do not decrease their size or length. But what usually happens in case of meridians is the distance between them usually decreases. Okay, that is the difference. Okay, that means as we go towards the pole, the latitude's length decreases, and in case of meridian, the distance between them decreases. That is the major difference. Okay, thus it was difficult to the number the meridians. So it was difficult to number the meridians, obviously, because it usually were like it is having a different set of orientation. Okay, so hence all countries decided that the count should begin from the meridian which passes through Greenwich, where the British Royal Observatory is located. So kind of, now you might be wondering why only the east side of the earth is called east side, and why the west side is called the west side. Because it was decided by all the countries, okay, that the line which passes through the Greenwich, where the British Royal Observatory is there, should be considered as the imaginary line which would divide the earth in the east and the west side. Okay, so if maybe in past, if they would have decided any other longitude, then the eastern hemisphere and the western hemisphere's position might be different from today's present location. Okay, so it was decided during a meeting, okay, in a meeting which was done. Okay, so this meridian is called the prime meridian. So that means the line which divides the earth into two equal parts in the eastern and western hemisphere is basically called as excuse me, is called as prime meridian. Its value is 0 degree longitude, and from it we count 180 degree eastward as well as 180 degree westward. The prime meridian and 180 degree meridian divide the earth into two equal halves, the eastern hemisphere and the western hemisphere. So as we know, we have been discussing till now that the longitude usually divides the earth into two equal halves, which is the eastern hemisphere and the western hemisphere. Therefore, the longitude of a place is followed by the letter E for the east and W for the west. So obviously this also we know from the previous discussion about with the help of like when we were discussing about the latitude. Okay, same thing happens with the longitude also. We use the same suffix E and W, okay, as we used to do for latitude, which is NNS. Okay. It is, however, interesting to note that 180 degree east and 180 degree west meridians are on the same line. Okay, so that is very interesting thing. Okay, it means 180 degree east and 180 degree west would be in the same line. Okay, but on the opposite side of the 0 degree meridian, which is also the prime meridian. Okay, so that is a very interesting thing. Okay. Now look at the grid of the parallels of latitude and meridians of longitude on the globe, figure 2.6. So whenever you will look at, so in here if you may see, there's a grid formation. So with the help of this grid structure, it will be very easy to locate any position on the earth. Okay, so that is the reason why we right now are using, or we have been using, you could say, longitude and latitude to exactly indicate a position on the earth. Okay, now and here what else they are saying is, see, you can locate any point on the globe very easily if you know its latitude and longitude. For example, Dhubri in Assam is located at 26 degree north latitude and 90 degree east longitude. So that is the best example which we could get. Okay, that means Dhubri's position, if you only consider latitude, would be 26 degree, but on 26 degree north latitude there are so many different places. But if you want to know exactly where is Dhubri, so you would need another line of reference, which is longitude 90 degree east. So with the help of 26 degree north and 90 degree east, we would be able to locate Dhubri, which is in Assam. So if you change the latitude and longitude as well, so what basically happens is you would be able to find different locations on the earth. Okay, so find out the point where these two lines cut each other. That point will be the location of Dhubri. That means wherever these two lines, 26 degree north and 90 degree east, would intersect, that point is the exact location of Dhubri. To understand this clearly, draw equidistant vertical and horizontal lines on a paper. So you could see this example over here. Okay, so they are saying to make a horizontal and a vertical line. So with the help of this example, you could exactly say, okay, so that if you may notice over there, line 1 2 3 4 are drawn and line A B C D E is drawn. So line 1 2 3 4 indicates longitude and line A B C D E indicates the latitude, and the intersection of these two latitudes would indicate the position of anything. Okay, so it is very easy. Like for example, if there is a object or place on earth which is at point A, it means it is between the longitude 1 and latitude B. Okay, so but we don't use those kind of words. If we want to indicate latitude and longitude, we would instead use degree measurement and a suffix, which you already know what it is. Okay, so let us skip this part which is over here. You could read on your own and try to understand. It's quite simple. Okay, so now in here there's a figure. Okay, So there's a figure. Let me rotate the screen. It's not rotating. Okay, let me make it small. So in here, if you may notice, see, you could just turn your you could just switch your phones, your phone or your computer's screen, okay, with the option, and try to look at this figure. It's a figure which indicates the zones of the earth. So these are the various zones of the earth, okay, understanding. So these are what kind of zones they are. Time zones, the zones which we saw before in this section over here is heat zones. Okay, so heat zones are basically the zones which were caused due to the differential heating of the earth. Okay, but this time zone over here is basically the line which is passing is basically longitude. Okay, and it helps us to determine the time of the different places on the earth. Okay, so if you may notice over here, they have written +1, +2, +3, +4. okay, so what does this usually means is from the Greenwich. Okay, so if you go on the east side, okay, whatever time is on Greenwich, it is +1 hour, 2 hour, 3 hour. Okay, so if you may see in India, they have written +5.5 hour, means we are 5.5 hour ahead of Greenwich. Okay, and any places which is on the either side of the Greenwich. Okay, and in here if you may see, they have written -1, -2 something. Okay, so in here you could say that those areas which is having -1 in front of it, it is actually that much time slower than Greenwich time. So whatever time is in Greenwich is taken as the reference time all over the world. Okay, and any places, any region on the right side of the Greenwich would have a positive time, and any region on the left side of the Greenwich would have a negative sign of time, which means it is slower. Okay, but exactly it's not slower. Everywhere the time passes same, but if we take a reference, okay, if we are taking a reference, then we are taking the time of Greenwich as reference. Okay, and time passes everywhere same. Okay, but what the reason why they are doing so is, as you know, the daylight and the night, okay, is different in different hemisphere. So this differential lighting of the earth due to sun's the sunlight experienced by the earth is causing a differential experience in different part of the earth. So obviously that there has to be certain time difference. Okay, so that was the main reason for taking the reference of Greenwich as a line for deciding the time zones of the world. Okay, so that is the major reason. Okay, so now let us try to understand what is longitude and time. Okay, so the best means of measuring time is by the movement of the earth, the moon and the planets. The sun regularly rises and sets every day, and naturally it is the best timekeeper throughout the world. So obviously the movement of the earth helps us to keep time, okay, throughout the world, means it helps in proper maintaining of time all over the world. Okay, which I've already discussed. Okay, local time can be reckoned by shadow cast by the sun, which is the shortest at noon and longest at the sunrise. So this were you could say early methods or ancient methods, okay, where shadows of light would help us to indicate the passing of time on the earth, but we would not be able to exactly determine the time which is being passed, because in different season the casting of the sun shadow on the of any object on the ground or any other place or any screen is different. So that is a natural phenomena. So that's why this technique of understanding time with the help of shadow is not so convenient. Okay, so that's why we needed a solid ground at which we could measure time. So that is the reason why when the prime meridian of Greenwich has the sun at the highest point in the sky, all the places along this meridian will have midday or noon. Okay, so that was the reason. As the earth rotates from west to east, those places east of Greenwich will be ahead of Greenwich time, and those to the west will be behind, as I've already discussed with you. The rate of difference can be calculated as follows. The earth rotates 360 degree in about 24 hours, so that was exactly it's not 24 hours, but we consider it as 24 hours. Okay, so which means 15 hour and that means 15 degree an hour. That means as the sun shifts 15 degree every time, there will be a hour difference, or 1 degree in 4 minutes. That means sun passes or changes 1 degree every time when 4 minutes passes. Okay, so that is the simple rule. Thus, when it is 12 noon at Greenwich, the time at 15 degree east of Greenwich will be 15 into 4, which is equals to 60 minutes. That is 1 hour ahead of Greenwich. Okay, so that is quite simple maths. Okay, which means 1 p.m. That means there is 1 hour difference because 15 degree has been shifted. Okay, so that is what actually is happening. Okay, but at 15 degree west of Greenwich, the time will be 1 hour behind, so obviously the time would be 11 a.m. Similarly, at 180 degree it will be midnight when it is 12 noon at Greenwich. That means there is a total 12-hour difference, because as we know, there has been a multiple of 15 degree differences every time the full section of the earth has been rotated. Okay, that means 180 degree, if it is divided by 15 degree, there are so many there is around 12 hour difference. Okay, that means, as you know, when you divide whenever we divide 180 with 15, answer comes 12. So that means obviously 12-hour difference has happened. So at any point, at any place, watch can be adjusted to read 12 degree clock when the sun is at the highest point in the sky, that is when it is midday. The time shown by such a watch will give the local time for that place. You can see that all the places on a given meridian of longitude have the same local time. That means whatever positions on the earth, okay, that means whatever time you are in your place, you are being able to see the latitude, the longitude at which you are. Okay, everyone which is in that longitude will have the same timing. So that is the perfect example. So if there is a shift, okay, that means if you shifted from that longitude to some other longitude, what usually happens is there is a total change in time. Okay, so that is the major scenario. Okay, so why do we have standard time? So why do you think we have a standard time? So obviously the answer is very simple. To maintain a proper synchronization. Okay, the synchronization means proper, you could say, match. Okay, so if in the same country people are using many different watches, so it would cause a huge turmoil. Okay, so there has to be a regularity. So that is the reason why we need to have a standard time. Each country in the world has their own standard time. Okay, and they consider to have their own standard time, and they measure with a particular longitude which passes through them, which they officially decide to be their standard what they say, line of reference for the time to be measured, and it is called as the standard meridian. Okay, so the local time of places which are on different meridians are bound to differ. For example, it would be difficult to prepare a timetable for trains which crosses several longitudes. Obviously, that is the main reason. It would, as I've already told you, there will be a turmoil, there would be a problem in different longitudes, because as you know, when we shift from one place to another in the same country, we might pass different longitude. So if we are passing two different longitudes at a particular travel, so to every time when we would have changed the longitude, our time also would have changed. So it would have caused a huge problem, because every time we had, our whole focus would be just to set time. Okay, so that is the main reason why we need to have a particular time for a particular country, and each country have their own standard meridian to take time details from it. Okay, so let's read and try to understand. In India, for instance, there will be a difference of about 1 hour and 45 minutes in local time of Dwarka in Gujarat and Dibrugarh in Assam. So as you know, Gujarat and Assam is at a difference of many longitude, okay, between them. Okay, there's a huge difference of longitude between them, so that's why there would be time difference also. So that is the reason why we should have a particular standard meridian. Okay, so in India, the longitude of 82.5 east is treated as the standard meridian. So as I've already told you, there's a requirement of a standard meridian, so we are taking 82.5 east as a standard meridian. The local time at this meridian is taken as the standard time for the whole country. So obviously the local time at this meridian is taken as the standard time for the whole country. It is known as the Indian Standard Time, which is also called as IST. Okay, so now let us try to understand more. Okay, so in here what they're saying, Kabir lives in a small town near Bhopal. He tells his friend Alok that they will not be able to sleep tonight. A day and night cricket match between India and England has started at 2 p.m. in London. So this means that the match would begin at 7:30 p.m. in India and will finish into the night. So do you know what is the time difference between India and England? So India, located east of Greenwich at 82 degrees and 30 minutes east, is 5 hours and 30 minutes ahead of GMT. So it will be 7:30 p.m. in India when it is 2 p.m. noon in London. So that is the main difference in time. Okay, so as I've already told you, some countries have great longitudinal extent, and so they have adopted more than one standard time. So as you know, in Russia is a very big country, so there are many longitude which passes through a single country. So that time what usually happens in those kind of countries which is very big, that time there are multiple standard times meridian which is taken by that country. For example, in Russia there are as many as 11 standard times. So Russia has 11 standard time. The earth has been divided into 24 time zones of 1 hour each. Each zone thus covers 15 degrees of longitude. So obviously there are 24 time zones, so you must remember this. So it is very easy to remember. As you know, there are 24 hours in a day. Same way there are 24 time zones in the earth. Okay, and the difference is 15. Okay, and the best way to know is, as you know, there are 12 hours in your
clock, okay, and if you as you know, the longitude extent is 180 degrees. So when you divide 180 with 12, answer comes 15. So best way to remember 15 degree causes 1 hour difference is just to know that when you divide 180 with 12, okay, answer comes 15. Okay, so this is how you could remember. Okay, so and best way to remember the Greenwich longitude is just consider the 82.5 degree east value. Okay, so this value is very important to remember. So I was about to tell you there's a trick, but there's no trick. The simple trick is to learn it. So this is what you have to do. Okay, so now see, these are the question answers which you need to solve. Okay, and this is your fun activity you could do. Okay, so